In this video, I want to have a look at some examples of binomial expansions where we're trying to find specific terms or coefficients. So our first example asks us to find the coefficient of x squared in the expansion of 1 minus 2x all to the power of 5. So we know that in that expansion, if we did the full expansion, then our first term would have an x to the power of 0, our second term would be an x to the power of 1, and the third term would have an x squared, which is what we're interested in. So we're not going to write out the full expansion, we're just going to have a look and figure out what that third term is. So to help us do that, we're going to look at the relevant line in Pascal's triangle. So that line looks like this. Because we're looking at the third term, we're going to look at that third number, which is a 10. So when we write out that expansion, we're going to do the 10 multiplied by this whole term here, so that minus 2x all squared. So what that looks like then is our 10 minus 2x all squared would simplify to 40x squared. Now it hasn't asked what the third term is, it's asked just for the coefficient of x squared, so therefore the coefficient of x squared is 40. Our second example asks us to find the term independent of x in the expansion of this term here. Now, the other way of saying that is if we want the term that's independent of x, that's just another way of saying that we want the constant term. So this question's a little bit different because it doesn't have a 1 at the start here. It's got an x and it's got an x, 1 over x squared here. So what that means is that we're multiplying these two things together the whole way through our expansion. So our constant term is going to occur when our x's from each of these cancel out. So we could go through and do the full expansion, but we've got a power of 9, so that's going to be a pretty huge expansion. What we can do instead is think about what powers would cancel each other out. So we would need whatever we put this to the power of to be double what we put this to the power of so that those x's end up being the same power. So what that means for us, because we're looking at 9s, this one's always increasing and this one's always decreasing. We're going to end up having to put this one to the power of 6 and putting this one to the power of 3. So if we have a look at the relevant line in Pascal's triangle, we know that if we're putting this first term to powers, they're going to increase while this one decreases. So this first term where we've got that 1, that's where we would have had this whole 2x to the power of 0, then to the power of 1, 2, 3, and so on. So because we want it to have a power of 6, we're going to be looking at this 7th term here. Now that also makes sense because our powers are decreasing for this one. So they're going to start at 9 and work their way down until they were 3 when we got to this term here. So this is the coefficient we're looking at. So what that means is that the 7th term in that expansion will be 84, 2x to the power of 6, 1 on x squared to the power of 3. If we simplify those powers, 2 to the power of 6 is 64, and we get our x to the power of 6 is here. Now these will cancel out, just leaving us with 84 times 64. So that just leaves us with 5,376 as our constant term in that expansion. Our third example is a little bit different. It says that in the expansion of 1 plus kx all to the power of 6, the coefficients of x cubed and x to the power of 4 are in the ratio of 4 to 9, and we want to figure out what k is then, so what that coefficient of x is in that bracket. So if we look at the relevant line in Pascal's triangle, we've got it here. Our x cubed would be our 4th term, so that's going to be looking at our 20 as that coefficient, and our x to the power of 4 would be our 5th term, so we're looking at that 15. So we can write out our expansion in terms of having that k in there as well. And we know that if we find the ratio of the 4th term to the 5th term, that has to be in the ratio of 4 to 9. So what we've done now is we've written that x cubed divided by x to the power of 4 term, and that has to be equal to 4x cubed over 9x to the power of 4, because we know it has to be in that ratio. So now we can simplify down that x cubed, x to the power of 4, we can just get rid of those off both sides and just have a look at the coefficients. So we're getting rid of those x's. So that's then going to look like this, our k cubed and our k to the power of 4. Now we can simplify down that 20 over 15 by dividing top and bottom both by 5. And we've also divided through by k cubed, so we just end up with 4 over 3k equals 4 over 9. Now, if this were a more complicated problem, you could go through, flip the fractions, work through algebraically to figure this out. But we just know that that 3k has to be equal to 9, so that means that that k has to be equal to 3. So that's having a look at a few different types of problems involving binomial expansions.